Hey everyone, welcome back to Dan91's Garage. It's been a bit of an interesting week, so we're continuing some work on the turbo log manifold that we started making last episode. I've remade a few things, I've broken quite a few things, and I guess we just jump straight into it so you guys can see what happened. So last week, in the previous episode, we left off, these had just been cut to size, still had the paint on, so I've cleaned these up using a 3M red angle grinder wheel, and I've also put the V's or the chamfers back on these ends. I think they're supposed to be 37.5 degrees according to some sort of, I don't know if it's ASME or something, but either way they're around that. If you put a chamfer on the end of these, it's obviously easier to weld. You obviously get better penetration because you're already hitting almost the inside surface of the material and then sort of building up between the two. So that's obviously for thicker material and relatively light duty MIG welders. That's obviously going to help out a lot with the penetration. So as we saw last time, when you cut through this radius bend vertically instead of from its center line, you end up with an oval cross section. So if we have a quick measure up of it, 34.6 across the sides, and 36.1. So we're about 1.5 mil taller. So basically if I get a piece of 3/4 mil thick shim and then jack that up, the center bore of this oval will then be with the center of the T-piece. What I can do also is on the inside of this, if I grind a chamfer on the inside for the top section only, sort of thin at the edge, bit deeper here and then not much there, and leave the width alone, and do the same for the bottom surface, I can also then essentially port match this to this, so then there won't be any step. So anyway, that's about as ready as it needs to be. So I'm going to put a pause on this one, and basically I've treated myself another couple of brand new tees. So again, 1 1/4 standard thickness, which is schedule 40 WPB carbon steel. So what I'm going to do is basically repeat this whole exercise, but with a setup for the smaller radius bends. So these bends are obviously going to flow a bit nicer because they're a big rad, but there's a bit of a dodgy transition here that I can make the best of, whereas these line up perfectly fine, but obviously because they're shorter I'll have to add in a piece of straight pipe and an extra weld in here. But the internal bore of these is near enough size for size there, so I don't have to worry about jacking things up, scooping out the bottom of it. I don't obviously I don't have to take anything off of these this time. In fact, I have to make this bigger, so gonna take some material off both these sides and cut myself some small discs of straight pipe to fit on the bottom that will bring this surface level with this surface. Also, the good thing about this is I'm not entirely sure how tall this needs to be off of the engine yet. It might need to come away further than this, so I might be welding on 4 little rings to this anyway. So if I can do it to this one, have a nicer transition here, and then make this ring even longer, and these other ones here, we'll see how it goes. So just a quick bit of detail how to measure up to cut down the T's. So for the short radius bends, they're 53.5 mil from the bottom to the top, and obviously their outside diameter is 42, so to get to the center line we need to take off 21, which is obviously the radius. So that then gives us 53.5 minus 21, which gives us 32.5 mil from bottom to center bore. Now we know that the distance between these holes here on the flange was 70, so if we now have one sitting here coming out to 32.5, that means that from 70 minus our 32.5 gives us 37.5 mil that we need from the center of the T to the outside edge to match up with our short radius bend. So the T is 96 mil wide, which therefore gives us 48 for half of it. So 48 for half the T minus our 37.5 that we need left gives us 10.5 mil. So we've got to cut off 10.5mm or perhaps 11mm just to round it up and make it a bit easier. Then obviously the T's again 96mm wide, and the pitch of the ports here is 90mm, just the same as it was before. So again, we need to take off approximately 6mm from this centre joint, so it's going to be 3mm off this side and about 11mm off this side of the T. So that's the T pieces cut to size. Again, small amount off of here, so it was all sanding. Chopped these off on the big saw and sanded them relatively square to each other. Obviously, the more square and well fitted the joints can be, the easier it's going to be to weld, rather than sort of like wonky angles and stuff, and you end up sort of sticking MIG wire through the gap. But they came up pretty good in the end. Obviously, now I just need, take it off the tripod, a small section of straight pipe to go in here, obviously to lift this up so it's in line with that. Just have a quick measure up of the short radius bend we're trying to put on there. It's not the most accurate thing to measure in the world because you are trying to measure in fresh air, but 53.8-ish for that one. So these two are a pair. So I've got my piece of straight pipe, so I'm going to cut about 16 off of this one. I've already put the chamfer on the end for welding. 69.3 again. 69.3 again for the T. .54 this time for this one. Yeah, more like 54. So that one will probably need more like a 15mm section. So I'll chop them off both 16, one off of each end, and square them up, and we should be there with the bare materials. All I've got to do after that is bevel the edges back onto this. I'll be ready for test fitting and tacking. And this is how that went. Different chop saw this time. So this is a cold cut tungsten carbide blade, should cut any material kind of thing. So the only problem with it is it does sort of throw shrapnel everywhere. So contact. Well, that was scary. That's knackered. That's the end of that saw. So what we learned from that is, even though the blade is capable of cutting through steel section because it has tungsten carbide teeth, doesn't mean you should actually use it. A proper chop saw will have a vise in it, and that will hold the work steady and save it being pulled out of your hand by the blade. Now, when that happened, it cracked the fence at the back, which is basically the guide. It also damaged the gearbox quite badly. You can see some smoke come out of it. I mean, it's funny looking back at the footage now, and I did include it for a reason, but that could have ended quite badly. So from now on, we're going to stick with the big saw. And this is my big saw. So it's got an abrasive cutting wheel, a nice vise here for clamping stuff, and that way at least you can hold the work safely. It's a bit of a mess when you cut it, there's lots of sparks and stuff, and it's a bit dirty and dusty, but at the end of the day it's a heck of a lot safer than using a version without a vise on it. And also, never underestimate the usefulness of a simple angle grinder and a bench vise or a workmate. They're just as useful, but just make sure you clamp your workpiece securely so it can't fire itself across the workshop. So anyway, back to the rest of the footage. Let's see how that went. This I like. Much safer. There we go. pretty square now. So obviously I've been able to do the same to these and true these up, but these are a bit small to hold, so I'm going to try something that may or may not work, or we may end up with another exciting episode of what happened with the saw. Let me just go grab a thing. Well, here goes nothing, and definitely don't try this at home. So that end's squared up, this end's pretty square, so we can stick a Jubilee clip on it. And clamp our tube back together, apparently. And now we'll see if we can hold that without it flying across the room. That's intensely hot. So there we go, that's the first one done. I'll make the second one, and then we can start putting the chamfers back on everything. So there it is. The fit up's pretty good again. Can't really see a huge amount of daylight through it. Sometimes you do need to leave a bit of a root gap to obviously aid with penetration. And I've already put the bevels back on these, as you can see. I've gone for quite a heavy bevel on these. 45 degrees. Normally it's a slightly shallower angle when you're actually doing official pipe work, but I went for 45 just because it's easier to put on. I've cleaned up these using a 3M flap disc again, taking the paint off, and I've also given these a quick skim over as well, just to make them a bit shinier and brighter, so they match a bit more closely the finish of the short radius bends that are a different finish. I've left the stamping on it because I actually quite like that, so hopefully you'll sort of understand what the sort of general look of this is going to be, which is why I'm doing it with this sort of stuff. So there we go. Second log manifold I've ever made, so I'm very impressed with the way that this has come out, and I think it's going to help with the flow for this particular design. I had to actually open up the inside of this slightly because this is actually a thicker wall section. Even though they both are schedule 40 allegedly, this one actually had a thicker wall than this one did. So using some sanding rolls on the die grinder, just simply linished these open a little bit more, and that way they're now the same diameter as the inside of these. So yeah, I do have one question for the professional welders out there, and it's this end finish that I've put on the pipes as they go to the flange. Now obviously these already come with some sort of chamfer, and I've added a chamfer to mine as well. Now I obviously understand that with thick material you need to add chamfers to help penetration, and when you go pipe to pipe on a butt weld you obviously put a chamfer on both. Now I've put a chamfer on the end of these pipes to help aid penetration. Now I'm not entirely sure whether they should be straight without a chamfer on them and then do a big fillet weld round them, or whether I still need to leave these on to help with the penetration, but then I perhaps won't get quite such a big fillet going up the side of this tube. So if anyone out there knows the right answer, or whether in fact you can do both and it doesn't matter, then please leave that down in the comments below. So now we've got two sets of pipe work made, two different designs. Personally I prefer the short radius, simply because the transition here is a lot neater. Let me know down in the comments which one you prefer. I'm certainly not going to waste the other pipe work, even if I just weld it up just for some practice before I have a go at this one. That way at least I know my efforts will have come to something for the second set. Certainly learnt a lot playing with these pipes, and I'm very glad I bought the extra 2 set of tees and gave it another go. There's just one more thing to cover before we go. If you follow me on Instagram, you'll have seen that I made up some rings to go into the flange here. And what they're for is, obviously when you bolt this flange down to the heatsink, you won't be able to see where the ports in this flange are anymore. So what I've done is, from a strip of metal that I rolled around a socket, I've cleaned the paint off of them now so they don't get melted in there and glue themselves to it when you put a bit of heat on them. And you push them in to the ports themselves, and obviously the outside diameter of this is then fitted up and indexes on the inside bore of this. So now it can only be within 0.5 millimetre or so of lining up over the port, because you'll never be able to see this hole again unless you drill a massive hole in this flange, and that seems a little bit excessive. So that's what they're for. Obviously I'm just going to use them to tack this up. Once it's all tacked together, it'll be set, then I'll take it off and pull these out, because when you fully weld it, there's obviously going to be some penetration through here, and the last thing you want to do is weld this into the assembly, because then you're going to have to go back in and sort of peel these out in some fashion. So not bad fit up, if I do say so myself. Well, I think we'll leave it there for this week. Don't forget to like and subscribe. Thanks for watching as always, and I'll see you on the next episode.